Softmax activation functions. We have other activation functions like sigmoid and ReLU, but Softmax is preferred and overcomes the disadvantages of sigmoid and ReLU, where Softmax activation function keeps the output value in the range of 0 to 1. As well, it will be giving the output into probabilities. So if you sum all these probabilities, the total will be 1. So what exactly a softmax activation function does is it will be converting an output of neural network final layer into probability distributions. Okay, this is basically used for multi-class classifications. The use cases are recommendation system, sentiment analysis, image classification, and the formula for calculation is this. So where here z is the input vector, and this is exponential to the power of z. This is a constant, and the value of this constant is 2.41 some change. And if you look at the denominator, you are taking the sum of all the probabilities. So this is basically to do normalization and keep the ranges in between 0 and 1. So softmax activation functions, attention mechanisms, transformers, so all of them go hand in hand. So we know that attention mechanisms are used whenever very long sentences are there in neural networks and handling them becomes difficult. So only important words, input words are taken up, kind of thing. So I have a small calculation done by Fani Kulkarni here for this softmax activation. Let us say here we have a sentence called as the cat sat on the mat, and we need to identify the importance of the words. And if you look at the sentence also, we know that the, on, the, they don't have the significance or relative importance, while the cat sat mat, they have the relative importance. See, you can see here the you have the query for cat vector as 0.5, 0.2, key for cat vector as 0.3, 0.1, key for sat vector as 0.7, 0.2. Now the first thing we are doing here is the multiplication of the query vector with the key vector, and after that you are dividing it by root k dimensions. Root k is, if you look at the number of dimensions here, the number of dimensions are 2. So root of 2 is 1.41. That's why you're dividing this by this root k dimension. After that, we are applying the softmax, and you have just seen the softmax formula where you have the numerator as exponential to the power of input vector and denominator as, for normalization, sum of probabilities. And if you look at here, when I'm applying the softmax here, you're taking this, that using that formula, you're deriving the softmax. Now once you get the softmax, you'll be multiplying that with the value vector, and ultimately you're taking the weighted value vector sum. So this is in brief how